We're going to end with some, I don't know, it's just algebra. There's really no trig that we need to do in this chapter. Maybe that feels refreshing. We're going to begin by just talking about ratio and proportion, and this is stuff that I'm sure you have seen. We've probably actually even talked about it ourselves, like just in certain contexts. But a ratio is nothing more than a comparison of quantities by division. So we'd say the ratio of A to B is A over B, or sometimes you might see it as A with a little colon B, although that's not very common in mathematics settings. Just like anything that we might write as a fraction, we would always want to try to reduce it to whole numbers, like we would any reduced fraction. So here's a super quick example to begin with. We have a length of a room that's 30 feet and the width is 18 feet, and if we want the ratio of the length to the width, here's the only reason I'm really doing this example, is that the language matters. The order in which they give you things matters. If we want the length to the width, we have to make sure that means the length goes on top. So we'd put 30 feet over 18 feet. Here's the other thing that matters, that these units agreed with each other. Like if they gave it to me in feet and yards, I want to make sure I put them both in the same unit first. Because when you find a ratio, the ratio will have no units attached to it at all. Notice the feet cancel, right? So it's just 30 over 18, and then we just reduce. So like, let's see, 30 is 5 times 6, and 18 is 3 times 6. So we could cancel. So we would say that ratio is 5 to 3. Not so bad. Nothing nearly like, it's not a trig equation, guys. I'm not asking you to prove an identity. A proportion is nothing more than an equation that says two ratios are equal. It specifically has that structure. I have an equation by itself with nothing else set equal to some other, I have a fraction just by itself with no other terms added to it set equal to another fraction. I'm not adding or subtracting anything else. There's not even any other factors. I just write it as one fraction is equal to another one. And here's a fact. If in a proportion the cross products are equal. I don't know how useful that is, but people use it a lot with proportions. This is nothing more than what we get if we take the equation, that proportion equation, and multiply both sides by the LCD. So we already have the tools to do that. It just so happens, though, that if our equation that has fractions is in this form of just one fraction equal to one other fraction, we could do the cross product. So, for example, we could use this to solve a problem. Let's say we have an alloy is 5 parts tin and 3 parts lead. All right, they gave us basically the ratio of the mix. And we want to know how many grams of each are there in 40 grams of the alloy. The important thing to realize here is that they didn't give us, like, we don't know how many grams of tin or lead. What they just gave us is the total, right? So we know a total. And when we set up our proportion, we want to set it up in such a way that it references the total amount. So I'm going to compare the total with the amount of either tin or lead, and it makes absolutely no difference which one we choose. So do you want to choose tin or lead? Tin. Okay. Sound more excited when you say that next time. So we're going to set up our proportions in this, in this form. So the amount of tin versus the total amount. So when we set up our proportion, which, by the way, we know is going to look like that, right? One fraction equal to another. Let's say we put the tin on top and the total on the bottom. Then I know in one of these, I'm going to put 40 because that's the total amount of the alloy, and some unknown amount of tin up there. Now I've got to use this information to make our other ratio. What should that look like? What goes on top? 5, because that's the tin. And how about what goes on the bottom?
3.
No, because that's the amount of lead. What's that?
40.
Nope.
Is it tin plus lead?
Uh-huh. So what goes on the bottom? 8. If I have an alloy that's 5 parts tin and 3 parts lead, basically that means there's 8 parts total. And here's our equation that we'll solve. Fairly simple. You could, if you want, use the cross product. I think that's silly to do when it's faster to just multiply both sides by 40. You'll get the same result in the end. It'll just take you an extra step if you use the cross product. So 40 cancels with 40. 8 goes into 40 5 times. So we get x is 25. And what is 25? What does this x represent in this problem? Yeah, units? Grams of tin, yeah. And we wanted to know how many grams of each are in the alloy, so how do I get the grams of lead?
40 times 25.
Yeah, there's 40 total, so we just do a little subtraction. That's 15 grams lead. Huzzah!